I'm really proud that we have a special guest here, that we have VMT here, which presents now their solution they've sold with our Ensenso camera. And I'm happy to introduce Lukas Neumann and Andreas Redekop to that one. So it's your stage.
Thank you. Thank you. Thanks for having us.
Thank you for having us. Switching to this one?
Yeah, okay, perfect. Yes, thank you for having us. My name is Lukas Neumann. I'm a product manager at VMT. And together with my colleague, Andreas Redekop from technology management, we want to present to you one of our newest and maybe most fascinating technologies with the usage of IDS cameras, our VMT FrameSense. But before we start into the VMT FrameSense and the technology behind that, I want to lose a few words about our company to catch everyone up to speed. VMT is a company in the vision technology. We have over 25 years of experience in vision technology and system integration, and we're specialized mostly into robot vision, inspection, and 3D vision. And we do that mainly in the automotive industry and also life science. And our company is internationally and founded in Germany. And the biggest locations for our company, I have a little map for you, just to get an overview where VMT is placed, are mainly here in Germany. We have our headquarters very, very close to the IDS center here, actually, and then in the US and China and in Spain, just to name a few. And so if you all have an understanding now of VMT, we're now going to continue to present to you our solution. But before we start with that, I want to show you the actual problem that we're trying to solve with that. And to start with that, we're based in the automotive industry, and the environment of the problem that we're looking at today is the press shop and the body shop. And actually, it's quite between those parts. But as most of you might not be so familiar with these two production lines, I'll explain a little bit. In the press shop, the big metal parts that are used for the body of a car are being, as the name says, are being pressed and cut and put into the correct shape before they get shipped to the body shop and are getting welded together so they can be used later on. And the problem that we're looking at today is actually just in the middle of those two shops with the transportation of these big metal parts from one to another. So transportation from press shop to body shop, which can be just over the road to the next building or even another plant in another country. And to transport these big parts, there is the usage of containers. And I brought some pictures for you of some actual containers here, so you get an understanding what we're talking about. These containers are the best solution to transport very big parts that can be quite wobbly and get shipped from one location to another one. And with these containers, there are some issues that can face through the lifetime of these containers and the usage of them. On the next page, I want to show you about these issues that we're facing here. And you can divide these issues into basically two sections. One is the handling and the other one is the inspection. And the handling issue that we're facing here is with loading and unloading these containers. These containers, and especially the parts that are quite big, that are coming out of the press and need to be put into a container, they are very heavy and unergonomic to put into place. And currently, the most used method to do that is to do it actually with workers. So you take the parts into your hands, you have a colleague with you, so you have to take big parts and you put them into the container. And as you can imagine, it's very heavy. It's very hard work that none of us will want to do for one day or even a whole year. And there's an issue with these big parts. And the other issue there is that we cannot really exceed this problem with more staff, as there could be a staff shortage, or we need to improve the cycle time because these big parts cannot be lifted very good. The second part actually comes with containers, as they are being not only one-use items, but they are being reused. So they get shipped all around the world and being handled by some forklift drivers, which we all know can be sometimes a little bit rough with the containers they handle. And we have a lot of wear and tear there. So some parts of the container might be a little bit off and might be a little bit defected. So we can face some issues there. And the problem with that is that the container cannot be used to some point, but we don't really know the status of our containers because we have no way of inspecting them on a regular basis. The tests that we have at the moment are just stochastically. So we take every 100 container out of our production and we test them in our test house, in our test lab, and then we can see are the container is still good or the container is not good anymore. What we face with that is that we have production downtime. So the containers cannot be used and we need to shift them and then repair them. And then the production can only continue if we have a new one there. So these two problems are not new problems because these kind of containers are used in the production and especially in the shipment of the big metal parts all around the world and for a long time. So I can imagine that even Henry Ford used them a long time ago when he started manufacturing his cars. And from my point of view, as someone who's working in the body shop or in the press shop, I want to have an automated solution for that. And my automated solution for this first problem would require some desired points. Because if I would have a solution that could handle this with a robot, then some of my problems would go away. So I would be able to work without workers and get rid of these unergonomical types of work. And I could handle all these different container types and have the possibility to load the containers and unload them. But what I require for that is that the system is not only working with one container type, but it needs some properties. So it needs to be able to handle all container types that I have, because I might have a few different types, one maybe even for each different part. And I need to be able to have some kind of crash detection, because I don't want to install a robot there that then produces 5 parts and then crashes into my container. Because the containers can be slightly off, as I told you before, and over the long usage time, they can be, one arm can look to the right side, one arm can look to the left side. It should still be possible to put the parts into the container, even though the container is a little bit off. And for the second part of my problem, if the container is too far off, so if anything happens to this container, I want to know before I put the parts in there. So I don't want to know that the container wasn't good when I already tried the parts to put in there, but I want to know it before. So there should be an automated quality inspection even. So a quality inspection of my container, if one part of the container is a little bit off or is a little bit tilted, and then if it not exceeds a certain level, the production should still be possible. But if it exceeds a level, it should be marked as not okay. And these informations I want to even marry maybe to the container ID that I have, so that I can build something like a digital twin to my container to see whether some values are always going up with one customer that I have there, or with one production step, and that I can work with that. Those are a lot of requirements that I have for the system, but this would be the perfect automated system for this issue that we are facing with containers. And as this is a very old problem, you can imagine that a lot of people already tried it to solve it. But the biggest challenge here is always not with the robots or with the automation of the system, but it's always with the eyes. So to see this big container with high resolution was always an issue, because we're talking not about a field of view that's like for bin picking, just a small bin or a bigger bin, but we're talking about a really big measurement balloon that can be up to 4 meters by 2 meters by 2 meters. So you can imagine that's quite big. And now we get to a point where it gets very technical. So I want to give the word to my more technically colleague, so he can show you the solution that we worked out.
Thank you, Lucas. So since Lucas checked all the boxes he wants to have, or like in the name of the customer, my part of the presentation is now how we approach to solve this very particular, very special problem. And to get more abstract, or just you can stay seated and you don't need to walk through your room to get out and to get a feel how big this volume is. We have in Germany, we have the Volkswagen Caddy, and I think we are talking about a size this big, and the measurement part or the features we are looking to, they are the size of children's hands that's sitting on the back row. And so this is the setting we are faced with when we want to have a measurement volume this size, but also with a high precision and with a high variance, or the capability to cover a lot of variances. And as you see in the slide now, then there is the specialty that they can of the containers. Now we see real images or cut data of the containers. There can be up to 2 containers in one cell. So the image in your head, maybe with the Volkswagen Caddy with the seats in the middle, is suitable, so that we have a back row and we have a front row, and we need to be precise in the front and in the rear of the car, and in this case in the container. And then there are in one container, in one measurement piece, there can be also different levels which need to be measured. So maybe with a car part which is not that big, it is needed that we can have several, we call it levels of where parts can be placed. And in one container, we need to capture all levels, even when the levels are covered by roofs. And I think we cannot go that deep into the detail, but the most challenging containers, they have roofs between 2 levels where the visibility of the parts is maybe covered by obstacles or in any size. So the high variance on the containers and the data generation, those are the 2 main challenges we are faced with. And then we come to sensor criteria, and I think we are approaching the biggest question at the end of the presentation, why we are here and how we solve this problem. Because Lucas already told us we are talking about a very old problem. And we approached this solution with 2D cameras in the past. Yeah, but now let's just assume we have the perfect input data. And like you see here, I think this is nothing new, but these are just the top three informations or top 3 abilities of a sensor we are looking for when we decide which sensor we take for a project this size. And I think when you go deeper into detail, there is the integration, the reliability, the interface of the sensors. It's very important for having many systems which are then manageable, or which are then for us good to manage as an integrator of sensors. And then the next part is when it comes to sensor positions. Let's call me this like it is a wrestling between the customer and between the vision contractor, we as a contractor, we want to have a perfect position for the sensors. The customer don't want any of the sensors in the production cell because they are the robot have to avoid crashes with the sensor. And so we have to find a sweet spot where our needs are covered and also all the tasks and all the boxes the customer checked can be fulfilled by this system. And so we get back to the point where we designed an offline position for the sensors. And you see here, we are talking about 4 sensors for one of these production cells with a sweet spot where we can, where we, from our side, check the boxes that we can fulfill the needs of this particular measurement task. And yes, I talked about the boxes the customer checked, and even the customer even checked boxes which were not on the list by putting the car example through its paces. Sometimes you have more wishes and you want to have some extra features. And I think we had all of these problems, technical problems in this project. And we called it cut in, post out. So the first information the customer wants from us as a product is the 3D pose of the container. Like Lucas already told, the containers typically we ask when we have a problem where somebody wants us to have like an object shape capture where we need to detect a specific shape and to create a pose out of it. We ask the deviation between the cut data and the real world data. In this case, we are not allowed to ask this question because these containers are in heavy use. Sometimes they stand up to a few months out in the rain. Then they have different materials. They have different shapes. They are have different lifetimes or lifespans. They already covered in the production. So we have to create a pose out of and calculate a pose out of features which maybe not look like in the cut data. So we are not allowed to check the frame where it is because that's the old approach. We need to know exactly where the features are, where later the parts are put into, or put between them. And so the main challenge here is that they can be bended and they can be sometimes manipulated. And human body and brain, human brain body interface is pretty good. So when you see there's an obstacle, you can avoid it by putting the part higher. The robot is pretty dumb in this case, and it just tries to force it through. So we need to create a perfect trajectory to put the part in a bended container. And I think that's the main goal for calculating the pose. And the second box the customer checked is that, of course, you don't want to have the locking mechanism in an unknown state, because those containers, and this is, I think, one of the challenges, they are designed to be operated by humans. Maybe 80% of them are optimized for destacking, but not stacking. So the system needs to check if there is any misalignment of locking mechanisms. They can be big, they can be small, they are often operated by humans. So they are levers which are behind some structures, and they have to be checked and the position have to be recognized and also monitored and then reported to the control system in the next level. And also like an interference contour monitoring, where it is checked that there are no obstacles in the way, or maybe the container is partially filled and the forklift driver just didn't see that there are parts still remaining in the container. So the robot and its counting in the background is maybe wrong. So we need to detect the emptiness of the container. And the third one, and I think let's assume that the first 2 points are good. And we have a good post result. We have a very good vision of the locking mechanisms, and they are open, everything's fine. And like in a good partnership, let me compare it. There is one friend, I like to go canyoning, and there is one guy who's always jumping in every lake, and he sees that there's a lake and I can jump into it. But there is this guy who's always saying that, oh, take care. I'm a little skeptical. And I think in this case, in our system, we have both parts. we have the pose, and every time the pose is created, like the position data, it is very forgiving. So we need to calculate a pose even if the parts are bended. But the skeptical part in our software, let's call it, we have the voice of reason is checking that, and the crazy friend is the pose. And the voice of reason is checking the container for its shape and also for its quality. And we are doing it by comparing the cut data with the real world data. And this is maybe the second term here is cut in and quality out. The container health tracking, this is like a buzzword for us, but it's checking the container shape for against the cut data. So you see in the image on the slide that there is colored information for fitting one of the features from cut to the real world. And where the color deviates too much, we see that there is maybe a breakout or a local deformation, or the builder for the container used maybe not specified materials, and the container is out of shape by design. So this is one big task that we see, that there are no teeth, no teeth or ripples which are broken out and are maybe in the way of the parts, or maybe a crash is then can occur later because of this deformation. That's part one. And then we have the displacement check. So we check every feature for its 3D position or 6 degrees of freedom relative to the CAD origin. So we need to measure the real world data and put it into the shape, put the shape exactly over the cut data, and then compare if one of the features or all of the features deviate too much, and maybe the crazy friend was wrong and the lake is too shallow to jump into, and stop the robot from putting parts inside. And yeah, this is what we call then container health tracking. And from one slide from Lucas, there is the possibility later to log the data to the container ID and to provide this information to an upper level control system. And then just shortly, after all engineers are happy and clapping themselves on their back with this well-structured and good chaos, sensible operations, everything's fine, everything's working, the next person who's looking to the system is the guy with the forklift and is understanding nothing. So this is the last part in the software, and it was the last part in our journey to create an easy front end where we can have this complex calculations in the background monitored to a user-friendly software, because the guy is putting the container onto the table, pulling a rope, and wants to know if there's anything wrong or why is the robot stopping or not starting putting parts in the container. So in this case, less is more, and I think in there is the software we are providing is very high flexible. But yes, now I think sensor selection, and here is the point where we are here selecting the right sensor for this application. Before we take any sensor, every sensor in our house undergoes numerous tests, and we put it through its paces. And especially for this project, which had great potential for scaling right from the start, the question of the sensor was one of the most I couldn't put aside after work and during planning and the testing phase. So one thing, paper is patient, and all the data sheets there put on exactly that paper. So we are referring back to the tests we have in-house with the sensors from various suppliers, and it's worth weight in gold at this point. So the experience we have had with Ensenso sensor family set the course here for this option. And with this in mind, we started a survey, we started abroad, and it's like when you go on a trip and you don't know exactly what you're facing, you take the best tool you have and you take the tool which you rely the most on, and you trust that the margin you have for special tasks or for things you maybe not covered by thinking about it, and you take it with you. And so we started here, and I just put the 3 points, the top 3 points from our prior list, with field of view and the high resolution and the high acquisition time. And yes, this sensor by checking boxes or speaking about that, checked all the boxes we needed. And I think the last part is here. The most important part is a very strong partnership. And I think in this process or in this project, we faced a lot of problems. And I think with the presentation before, we saw that there are a lot of them. And in this case, I remember meetings with IDS Ensenso where we sat together and described our problem and got solutions, and where we set the goal, and the result was let me call it like this, is a customized off-the-shelf sensor where we highly rely on, and where we get the perfect data. And you see in the slide the quality of the data, which matches the small children's hands on the backseat of the Volkswagen Caddy I mentioned before. And to wrap this up with the last slide, a new sensor that solves all problems. This problem was approached a lot of times by us and by other companies like us. But this kind of solution is the first of its kind, because we have problems which were there all the years, but we waited for a sensor and technology which makes us able, with the right software and the right usage, to solve them to happy customers and also to happy users like us. And in this three images is just speaking about emotions. This is not about technical issues, but here you see the test cell abroad and the team who was able to manage it, to cover all the boxes, to cover all the problems. And I think there are no competitors anymore. You only see happy smiles. This is a 3D point cloud image from the pre-series, and the next series is just even better. And I think this is a very successful story, and we are happy to have this partnership here. And yes, are open for questions. And I hope we don't forget anything.
Thank you. Yes.
So thank you very much for your really interesting talk. I have two questions. So one would be, you told your application can scale. So in my mind comes either scaling in size, so where can it scale? Also scaling application. What kind of other applications would be solvable with such a solution?
I will forward this to the product manager.
Yes. Coming a little bit forward. So maybe first to the second point, scaling it for applications. We now have the possibility to measure big field of views. So what was not possible before, what made this possible, as possible to scale it now to any inspection or even any measurement of this big kind. So if you would want to measure a whole car, or if you want to measure another big part that's as big as a car, then it's possible to do with multiple sensors. Not only one field of view, but many combined field of views. And the second thing about scaling is, scaling the whole system. So with accuracy, we're quite limited to the field of view that we have. We cannot look with multiple sensors and expect the double accuracy, but we could scale it even with more sensors. So if we would have a bigger field of view, we can use even more sensors. So we're not limited in this direction, kind of, but it's scalable still to go out.
Maybe to add one information, even downscaling is possible. So if we are talking about intralogistics, where we have small conveyors, small parts, this is all about like system design. But in architecture, the system delivers like all the bed we need to create this.
Yes. And for other containers, maybe also. So there's told us now we can scale down. We can also have a look at smaller containers that face also these issues, or other parts that face these issues that get disformed, and we want to see that. So.
Perfect. Thank you. So I see there are a lot of further opportunities.
Yes.
Coming up, and where a lot of Ensensos are also.
Yes, we're happy to use that.
So thank you very much for your presentation. There's one question coming.
Yeah, please. Yes.
How does Ensenso C behave with the reconstruction of transparent materials? Do you have something in this application?
So from my side, I have to say I didn't test them with transparent materials yet. So the materials, as you see here, they're metally and painted a little bit, but I'm not sure if you have tested them maybe in our lab.
I think this is a big topic for 3D sensors, because like sometimes there you have semi-transparent materials, and we discussed that prior here, that we have the main challenge here is that the sensor is not only providing good information with metal parts, but also like mixed materials. So there the challenge is that there are we cannot know which part or which rubber part or which kind of plastics the customer is using for the next container. Maybe there are some translucent parts, and we have to cover this. But by stereo matching, and this is why we are also rely on the Ensenso sensor, because there is this like a stereo camera architecture. We are very confident that we will get it, but we don't test it completely transparent.
But we will. Yes, this is also in our scope to see, as we do with other sensors that we use for other applications. We want to see especially the hard materials, not the ones that we already know.
Like packaging, which is an obstacle in the container, we will see, but maybe we cannot measure it with precision.
Okay, thanks. So, and if you have topics with transparent material, just contact IDS and let's see what we can do together and if we can solve your issue. Okay, so that's what it for the question. Again, thank you very much. I'm really proud that you joined us for this session today.
Thank you for the invitation and having us here.
Yes,
thanks.
Thank you very much.